All right, so in this video, we're going to talk about how we calculate calories using a calorimeter. So we know that calories, I'm not going to read this definition. I'm just going to talk about it in terms of like regular English, right? So calories is just how much heat or how much energy is in food, right? And this is the equation we use to calculate calories. So this Q or heat energy is how many calories is in the food that we're calculating. So to figure out calories, I need to know the mass or the weight of the food. C stands for the specific heat of the food, right? So how fast something heats up. The tricky thing is we don't know the specific heat of the food, but we do know the specific heat of certain elements and also water. So, really, in calculating calories, we just use water because we know the specific heat of water, right? So, when we're doing these calculations, the specific heat of water or H2O is always going to be 1 calorie per gram degree Celsius. Doesn't that make our math so much easier, right? So your C when you're calculating calories is always going to be 1, right? And then you also need to know the temperature change of the water, right? So these are the 3 things. Actually, it's 2 things that we need to record because we already know that C or specific heat is 1. So we need to know the mass of the food and then the change in the water. All right, so let's go into the next slide to talk about how a calorimeter works and how we use that to figure out what numbers we need to plug into this equation. Okay, so this device on the right-hand side is a calorimeter. So usually what you do is, let's say I have some butter. Whoops. Say I have some butter in this dish and I want to figure out how many calories it is, right? So first I need to know the mass of the butter that I'm measuring. So I need to know the mass of the butter. So let's say our butter weighs 16.11 grams, right? And once I know that, I can place it inside this device. All right, so step 2 is I put it in this machine called a calorimeter. So in the calorimeter, when I close this device, it's going to fill up with water. And the reason why we use water to calculate calories is because we know the specific heat of water, right? We know that in the previous slide, we said we need to know the equation for calculating calories is Q. So Q is calories equals the mass times the specific heat of water times the temperature change of water. So this triangle just means temperature change, right? But if you are burning a whole bunch of different foods, you don't want to calculate the specific heat of all the chemicals in all those foods all the time. So because of that, we know that the specific heat of water is 1. So that's what we use. And the reason why water is in here is because when you burn this and it gets super hot, all of the heat energy will go into the water, right? So let's say we already know the number of calories in the butter. So let's say our butter weighs this much and it has 10 calories, right? So if our butter has 10 calories, all of that energy is going to go into the water and heat up the water, right? So now there's 10 calories of energy in the water. And those 10 calories of energy in the water is going to go into these coils where we can measure the temperature, right? So we can now measure how many calories is in the water based off of its temperature change. And we know how fast water heats up. and we know the calories of 1 gram of water, so we can use that to calculate the calories of any type of food as long as we transfer all of the heat energy into the water, right? So I burn this up and then I measure the temperature change, right? So let's say when we first started out, we measured that the temperature was originally 20 degrees Celsius. And then after we burned it up, it went up to 33.2 degrees Celsius, right? So when I subtract these two, that's going to be my temperature change, right? So going back to the mass, we know the start of the mass. Now we need to know the end of the mass because sometimes not all things completely burn, right? So going back to that same orangey color. So let's say we burned most of the butter, but actually, let's say we didn't burn a lot of the butter. We started out with 16 point something, and then the mass of butter after is going to be 15.01. Right? So if I want to figure out the mass, I'm not going to use either of these separately. I want to figure out the mass of the butter that was actually burned because that is how much energy went into the water, that went into the coils, and then got to our temperature so that we can use that to calculate calories, right? So that's why we're only figuring out how much um, the butter burned. So if I started out with 16.11 grams, and after I burned it, I'm left with 15.01 grams. Well, if I subtract these two, I can figure out how much butter actually burned. So if I subtract those two, only 1.1 gram of the butter burned. And if I subtract these two, 20 minus 33, the temperature change, I'm going to make it in the same color, is going to be 13.2, right? So know that I flipped these, but take the absolute value or always take the positive number. So now I have my three parts. I know the mass of the butter that burned. I know that the specific heat of water is 1. And I know my change in temperature is 13.2. So now I have everything to plug into my equation. So if I have 1 gram of butter, how many calories would that be? Well, it would be 1.1. I got this from subtracting the two masses before it burned, after it burned, times the specific heat of water, because we know how much energy is in water, 1, times the change in temperature, right? So we started out at 20 degrees and then it went up 33.2 degrees. So change in temperature times 13.2, right? So if I had 1 gram of butter, I'm going to need to multiply all three of these numbers. I'm going to do that on my calculator right now. 1.1 times 1 times 13.2 is going to be 14.52. So 14.52 calories in 1.1 gram of butter, right? So this much butter will have this many calories. Now, know that this is lowercase c calories. So lowercase c calories is different from capital C or big C calories. So a side note that you should know is that one lowercase c calorie is the same as 1,000 capital C calories. So on the food labels, if you go grab like a snack right now with the nutrition facts, you will see that all your food labels are in capital C calories, right? So your food labels are kind of a lie. They're not really a regular calorie. So if you check your like Cheetos right now and it says it's 100 calories per bag of chips, it's actually 100 times 1,000 calories. So what is that? 1 million calories? Right. So that's how much it actually is. Slightly less than a million, 100,000. Right. So a bag of Cheetos is actually 100,000 calories. Not true. Right. So just a side note so that you are aware. But when they say that you need 2,000 calories a day, they're also thinking about big C calories. So now at this point, you should be able to calculate calories or have a general understanding of how to calculate calories using a calorimeter. In the next video, I'll do a couple more practice problems on how to calculate calories.